Dear friends, this question is a doubt of many students. Question is from JEE Mains 2016. Question is based on thermodynamics. Question goes like this. An ideal gas undergoes a quasi-static process, reversible in nature, in which molar specific heat C of the gas remains constant. During this process, the relation of pressure and volume is given by PV power N equal to constant. Earlier we had adiabatic process in which relation was PV power gamma equal to constant. So since here gamma has been replaced by N, so process is not adiabatic in nature. Then N is given by, in terms of course Cp and Cv, which we have learned as molar specific heats at constant pressure and at constant volume. Options are like this. N is equal to Cp by Cv. N equals C minus Cp upon C minus Cv. Third option, N equal to Cp minus C upon Cv minus C. And last is N is equal to C minus Cv over C minus Cp. So this is question number 83 in the booklet which you have received either from Mentors sector 46 or Fusion phase 7. So question number 83 of thermodynamics, it is already given in your book. So first of all, since dq equal to du plus dw, the first law of thermodynamics, heat given to a system is used partially in increasing internal energy of the system and the remaining goes for doing work. Since we have to discuss the result for molar specific heat C, in terms of C, the heat given to a system equals N times, that is number of moles times, the specific heat into rise in temperature. Since we have to derive relation for specific heat only, in terms of C only, C, Cp and Cv, so we'll consider only 1 mole of the gas and we'll increase the temperature by 1 degree C. So dq should be equal to N, that is 1, C, that is specific heat, into rise in temperature, again 1. And du, as you have already discussed in thermodynamics, du equals ncv dt. So here it should be 1 number of moles, Cv into rise in temperature, that is T2 minus T1, final temperature minus initial temperature should be equal to 1. Further work done, we'll use the expression for adiabatic process. In adiabatic process, you had PV power gamma equal to constant. So work done in adiabatic process was Nr over gamma minus 1 into T1 minus T2, as you have learned in chapter thermodynamics. So here PV power gamma is replaced by PV power N. So I must write N, that is 1 mole, into R over gamma, that is N minus 1, into, here you had T1 minus T2 during an adiabatic process. Since dt stands for change in temperature T2 minus T1, so if T2 minus T1 is 1, then T1 minus T2 should be equal to minus 1. So the relation can be simplified as C equal to Cv plus R over N minus 1 to be changed due to minus 1 as 1 minus N. Now we'll proceed further. Since R is equal to Cp by Cv, so let's take this Cv to left hand side and replace R by Cp minus Cv. Further multiply 1 minus N to the left hand side term. So on expansion you will get 4 terms. First of all, 1 into this whole term is equal to C minus CV. Then minus n into this term would be equal to minus nc, and minus into minus plus n into CV. Right hand side CV minus CV. Further, CV would cancel, both are minus CV, and you are left with C. Take this CP to left hand side, CP, minus N to right hand side, plus NC, and this one would become minus NCV. Since we are interested in value of N, so take N common. So you are left with C minus CV on the right hand side and C minus CP on the left hand side. Now simply divide by C minus CV to get the value of N. So our answer is C minus CP over C minus CV equal to N. But if taken a negative sign on numerator on denominator, you will get Cp minus C equal to divided by Cv minus C also. So actually these both choices are correct choices. So either you mark choice number 2 or you mark choice number 3, both the answers are same. So as written in the answer key supplied by CBSE, so I am marking answer number 2 to be correct, but 3 is also the correct answer. So students who have marked either 2 or 3, both will get the marks for the same. So let me repeat the process. First law of thermodynamics, dQ equal to du plus dW. dQ is equal to number of moles into specific heat of the gas C into rise in temperature 1. Further, du, that is equal to n Cv dt, usually replaced by, so n is equal to 1 Cv into change in temperature equal to 1. Work done, we have taken the expression from adiabatic process in which there was PV power gamma equal to constant. So you can write nr over gamma minus 1, that is n minus 1 into change in temperature. But here you had T1 minus T2 in fact, and this 1 stands for T2 minus T1. So T1 minus T2 has to be minus 1. Expression nu C is equal to Cv plus R over 1 minus N. You can remember this formula for any polytropic process like this one. For adiabatic process, you may have R over 1 minus gamma. Now take Cv to left hand side, substitute for R, Cp minus Cv, take 1 minus N to the left hand side, multiplied, open the brackets, Cv cancels, take N's to right hand side and Cp to left hand side, take N common, just divide by C minus Cv, you will get the answer. Hope you would have enjoyed, understood. Please like, subscribe and share the video. Thank you for watching.